Functions. So cubic functions take the form of ax cubed plus bx squared plus cx plus d, where the highest power of x is a cube. If the coefficient of x cubed is positive, then we say it's an n-shaped followed by a u-shaped. And if the coefficient of x cubed is negative, then we end up with a u followed by an n. Now, if we just have an x cubed graph altogether, then what we can end up with is a saddle graph. When we look at cubic functions, we say they can have three distinct roots. So in other words, it can cross the x-axis at three different places. Or they can have three real roots where two are repeated. So in other words, it sits on the x-axis or it straddles the x-axis. And it can also have one real root where two are imaginary. In other words, it only cuts the x-axis once. So let's look at sketching an example of a cubic function. So this is the example on page 144 in your textbooks, where we're asked to sketch the mapping function of x being mapped onto x cubed minus 5x squared plus 3x plus 9 in the domain of minus 1.5 to 4, where x is an element of the real numbers. So in other words, what we're really drawing is the function y equals x cubed minus 5x squared plus 3x plus 9. Now, you can break this down into 0.5s, or you can just sub in for minus 1.5 and then go up in ones. I think we really have enough points here to get a good shaped graph from our cubic by going minus 1, 0, 1, 2, 3, and 4. But of course, we have to start at minus 1.5. So wherever there's an x, I'm going to put minus 1.5. And we get our output, y, which is minus 10.13. If I then sub in for minus 1, I get my output is 0. If I sub in for 0, I get 9. If I sub in for 1, I end up with 8. If I sub in for 2, I end up with 3. If I sub in for 3, I end up with 0. And then if I sub in for 4, I end up with 5. So sketching each of your points, so out to the x-axis up to the y-axis, we know our scale for our x must go between minus 1.5 and 4. So you might start at minus 2 and go to 5. And then on your y-axis, we can see that our lowest value is minus 10.13. So you might draw down to minus 11. And our highest value on the y-axis is going to be 9. So you might scale it to 10. So when we plot our graph, we can see we have an n followed by a u because this was a positive x cubed graph. So let's look at the questions that we're going to be asked based on this graph then. So the first one is the values for which f of x is equal to 0. So when f of x is equal to 0, basically that's another way of saying, i.e., where is y equal to 0? And of course, y is equal to 0 where it cuts the x-axis. And we can see it cuts the x-axis at x equals minus 1 and x equals 3. The second one then says the value of f of 2.5. So that means when x is equal to 2.5, what is y? So x equals 2.5 is the line that passes through 2.5 and is parallel to the y-axis. So if we draw our line through 2.5, then to find our y value, what we now do is find that point of intersection with the graph and go across to the y-axis. And then we can simply read off where does it cut the y-axis. And we can see that that value is approximately 0.9. So again, depending on your graph and how accurate you've drawn it, you might get a slightly different value. So the next one wants us to find the minimum value of f of x where x is greater than 0. So what that means is the smallest value of y where x is positive. So greater than 0 means x has to have a positive y value. So of course from what we've sketched here we could see, well, there's the lowest value of y. It's just over minus 10. We said it was minus 10.13. But of course that would give us a negative value for x. X is minus 1.5. So therefore that can't be included in our answer here. So then as we go along our graph, if we follow the green line up, our value for y is increasing until we get to this point here. And then what happens is our value for y begins to decrease again until we get down to this point here. And then what happens is the y value begins to increase again. So therefore, the lowest value for y has to be when x is equal to 3. So when x is equal to 3, we see y is equal to 0. So therefore, our minimum value of y, or f of x in this case, is equal to 0. So the next one wants to know what values of x will give us y decreasing. So the values for x for which the function is decreasing. So when reading our function, we always read from left to right. So we read in that direction. And therefore, if I look along my graph here, we can see my function is increasing. So in other words, the y values are getting bigger. And then we reach this point here and the y values begin to get smaller. So we say the function is decreasing until it reaches 3, 0, and then the function begins to increase again. So therefore, the values for which x is decreasing are between these two values. So between our highest and our lowest point. So therefore, if I look, my range of values for x then are going to be between, so we go 0.1, 0.2, so approximately 0.3. And then we have 3. So we would say approximately 0.3 and 3. So at 0.3 and 3 it is neither increasing nor decreasing. But once I go beyond 0.3 and before 3, it is decreasing. So we would say it's less than x, less than 3. Okay, so the next one then is the solutions of x cubed minus 5x squared plus 3x plus 9 equals 2. So remember, the question said we have to use our graph. So we can't use our algebra to solve this. It has to be from the graph. Now, if we spot here, x cubed minus 5x squared plus 3x plus 9 was our function that we were given. So that's f of x. So basically, this question is just asking us to find where is f of x equal to 2. And of course, f of x is the same as saying y equals 2. And y equals 2 is the line that passes through 2 on the y-axis and is parallel to the x-axis. So once we draw this line parallel to the y-axis, we can see that it cuts the line 3 places. So cuts it at approximately minus 0.872, at approximately 2.212, and at approximately 3.662. Now, of course, I have graphed this using GeoGebra, and therefore I'm getting correct to 2 decimal places. But for you, from your graph, you'll probably just get approximation. So therefore, 1 decimal place would be more than enough to write your answers down. So in other words, the solutions are, there are 3 points where the line intersects the graph, and therefore that's at x equals minus 0.8 or 0.9, depending on what you're getting, at x equals 2.2 or 2.1 or 2.3, so it might be in and around there for you, or at x equals 3.6 or 3.7 approximately. Okay, and the last question then is where we have x cubed minus 5x squared plus 3x equals minus 4. So this time if we look at the left-hand side, what we'll find is that it's not the function that we have. So if I bring everything to one side, I have x cubed minus 5x squared plus 3x plus 4 equals 0. So it's still not the function I have. My function is x cubed minus 5x squared plus 3x plus 9. So in order for me to make this plus 4 become a plus 9, well, what I'd have to do is add 5 to it. But of course, mathematically, I know if I add 5 to that, then I'll have changed my function. So I need to do the same to both sides. So if I add 5 to the left, I must add 5 to the right. So now I've done the same to both sides. I haven't changed the value of my function. So that gives me x cubed minus 5x squared plus 3x plus 9 equals 5. And now I can see, well, that's f of x. So this now has become the same as the previous example. It's where is the function equal to 5? In other words, the line y equals 5, where does it cut the graph? And this is a little higher up than the previous one, and we can see it cuts the graph again 3 times at again x is approximately minus 0.62, x is equal to 1.62, and x is equal to 4. So again, you'll get more rough approximations than I will, but they should be in and around these answers. All right, so what you're going to do is you're going to sketch the graphs on page 145, and then you're going to put them into context doing some word problem graphs. So you're going to do question 2, 3, 10, and 11.